Hi, I'm Ryan Kooiman, Director of Training at Standard Motor Products, and I want to welcome you to this month's Power Hour. Today we're focusing on critical sensor relearns. What has to be done to complete the job? Now, this is one area that quite often technicians overlook. We're all really good at putting parts on, right? But there's sometimes steps that have to be done to complete the job. That's what we're going to focus on here today. So let's get started. All right, so I mentioned our topic today is critical sensor relearns. So it goes across a ton of different categories. I've only listed a few examples here. And I'm going to touch on a lot of these, but obviously not every one of them here. And sometimes it's more of a system relearn than just the sensor relearn, but it's stuff that has to happen after we've done the repairs there. And again, keep in mind, this is not a comprehensive list. This is just some samples. And so I'm going to say it multiple times throughout the presentation here. It's important that we as technicians always look at service information. Even though I've replaced a blend door actuator 100 times, well, depending on the year, make, and model, the procedure may have changed and the actuator internal design might be different. And so it may or may not require a relearn procedure when we're done, and they could be different from year to year. So that's where it's very important to look at service information when we're doing the job, preferably before we start the job, so we understand what relearns are done afterwards or required to be done afterwards. You know, there's nothing worse than bolting the parts and then going, I don't really have the tools to do this. You know, and I'm leaving off this list stuff like ADAS, tire pressure monitoring systems, huge categories that are very often going to require a recalibration or some type of relearn procedure after you're done replacing the product. So let's kind of jump right in here and start with electronic throttle control systems. So, you know, this is one of the great advents over the last 20 plus years of driver experience. We no longer have the old cable which binds up and the throttle body binding up there. So it all starts with the APP, an accelerator pedal position sensor. Got one on the bench here today. And so this is one of the crucial ones on many different manufacturers. When you replace this thing, there's going to be a relearn required. Some of them, it's going to be plug and play. Other ones, I'll say, such as Volkswagen, some of the older models, you had to do a relearn. And there's actually a kickdown detent here, and so you had to do that relearn. Failure to do the relearn on the APP system on Volkswagen is going to cause the AC compressor not to engage, and it's going to mess with the cruise control as well as the idle. So it's important on many models with APP to replace it. Now that's our input device to the PCM. That's the driver's request saying, this is how fast I want to go or how much torque I want the engine output. It's going to look at a lot of different inputs here, make the consideration that's going to command the throttle body to do what it needs to do. But it needs to know where that throttle body is and where the minimum idle is on that particular one. So anytime an electronic throttle body is replaced, it's super important that we look up the information to determine if a relearn is required. And so as we look at a couple different manufacturers here, you know, these are general, and this might be right for the car I looked up on this particular day. It might not be the same for the vehicle you're working on there. And so GM's going to say to start the vehicle up, make sure it's warmed up there, idle it for 2 minutes in these different conditions here. Obviously park with the AC off. There's not a whole lot of load on the engine at that point. Now as we turn the air conditioning system on, it's going to increase the load, and so the throttle blade should be opening up. Same thing, we keep our foot on the brake pedal. You know, we put it in park and we go through here, or excuse me, into drive rather than park. It's going to change the idle settings here. I put this additional little note on here because I've run into that in numerous GMs where you just couldn't get it to do the relearn there. And so found great success, especially with some of the early 2000 model year vehicles, to go in and do a complete module reprogram. That's going to wipe out any predetermined or pre-learned values there, and it's going to start fresh, and then it will allow the relearn to occur there. Now, that's definitely not saying that we have to reprogram the module every time we do a throttle body, but sometimes on some vehicles, that's going to be a necessary step. Now, Ford is going to ask us to reset the keep alive memory and idle the vehicle really in those same conditions which we've seen there. And then again on forward, we're going to look at certain data PIDs, and it's going to give us an indication as to what that throttle angle is in that new learned position. Chrysler, this is not my favorite thing to do, is to disconnect and reconnect the battery. You know, we lose a lot of memory and a lot of different modules at that point, and quite often we run the risk of spiking a module upon the reconnection there. But this is a recommended procedure on the vehicle I looked up here. And so they're going to say disconnect the battery. Now I'm going to let it go a good 10 minutes at least, because we want to allow the capacitors to discharge and the system to fully go to sleep. You know, if we just unhook it and hook it back up, we may not have done anything to the memory there. So now we're going to do key on, engine off for 10 seconds or more. And then that's what some of the older models say. Newer models were exclusively going to be doing the scan tool. And so you can see here, by using the Y-Tech in this particular vehicle, there's an output test here that says Learn ETC. And so we're going to go through the procedure, walk through the scan tool. It's going to guide you step by step on exactly how to do that particular relearn there. Now, this is everybody's favorite one, right? The Nissan. And so this is one that's caused probably some of my gray hairs here, and it's difficult to do. I want to acknowledge that right off the bat. And so if you replace anything in the electronic throttle control system on Nissan, there's very specific procedures you have to go through. They want you to do an APP relearn first, and then a throttle valve closed position learning relearn procedure. Then we're going to get an idle air volume relearning. And ideally, we're going to do it with the scan tool. But certain models in certain years, I've had better luck in doing it manual here. And so again, conditions must be right. So I've seen some of these, and as I said, these can be struggles here. And I've run into technicians with the same problems I've had with them. If we're trying to do some of these and the engine idle is too high, right? We just installed a new component. It hasn't had time to learn yet. But if the engine RPM is too high, it's going to bail and kick you out of whatever relearn procedure you're in. And so that's where we have to get a little creative. I've been known to grab a clipboard before and kind of make my own throttle opening, kind of choke off the throttle there so that we could lower the engine speed. I've heard of other technicians unplugging fuel injectors, create a misfire so the engine's running so poor that it keeps it within that range there. And so I like that idea better than unplugging ignition coils. Quite often ignition coils are easy to get to, but remember, we never want to run the vehicle and take away spark while fuel is being enabled there. It's going to kill the catalytic converter at that point. So I don't want to fix a customer's drivability concern and now have them come back a day later with a check engine light on because the catalytic converter is faulty. So sometimes we have to get a little creative here to make sure the conditions are proper to get the relearn to occur here. And so this is the Nissan manual procedure here, and it can be done. It's bailed me out on several occasions. I'm gonna remind you at the end of the procedure, or at the end of the session here, to go to our YouTube channel. But I'm gonna say it right now, go to the YouTube channel and look up Nissan Relearn, and that should bring you right to a video that we've done this procedure with. And so it's very straightforward. We include the stopwatch in the video. So I would recommend, if you're working on Nissan, watch that video at least one time through, get a good feel for what you have to do, and then go through. And you can follow it step by step. And it'll walk you through this manual procedure right here to get that relearn to occur. So again, hopefully you understand a little bit about the importance when we're working on an electronic throttle control system, that there's different relearns we need to do on those particular vehicles. Next up is crank sensor. Anytime it's replaced or things related to the crank sensor, we need to do a crank relearn. So I've got a drawing here. This is from the Cadillac Northstar. You might be familiar with this, with a 4.6 liter. And it's got the dual crank sensors, 27-degree angle. And so you've got crank A and crank B. It's going to do timing-based crankshaft calculations here. But on most vehicles, we're going to have just one crank sensor. And the PCM has to understand what known good is before it can start making determinations about misfires and really even fine tune ignition and injection timing. And so anytime we touch the crank sensor, we touch the crankshaft, or anything bolted to it, a crank relearn in most cases is required. So once more, always go to service information and look that up. But here's a sample. If you're replacing the transmission on a Ford van, the final step here is perform the misfire monitor neutral profile correction procedure. And so keep in mind, different manufacturers are going to call it different things. This is Ford's terminology for it. GM, I'm sure many are familiar back in the old days. You know, I grew up working on the 5.7 Vortex and the 4.3s, and that's where we would go into our scan tool, we'd select it. The vehicle had to be in park, had to be warmed up, AC off, and it would tell you under the right conditions, now go wide open throttle. And so you'd rev it up to 5 grand, let your foot off the throttle, and then as it comes back to idle, that's when I'm gonna be doing the relearn there. So you would do it right in the bay. Now, here we are using a aftermarket scan tool, and we're gonna select misfire monitor neutral profile correction. And so right here in the scan tool, it flat out tells you on this 2018 Ford Transit 3.7, when should we be doing this? Anytime the PCM is replaced. That would even say if the PCM has been reprogrammed, because there's a good chance that memory block has been overwritten. So if the PCM has been cleared memory, internal engine repairs, obviously we've got different stuff happening inside the engine, so we want to do this, or crank sensor or trigger replacement. Here's the conditions. Engine should be at normal temperature. Gear selector should be in park or neutral. Obviously AC or defrost off, and then follow service information for any additional requirements. So again, we often refer to service information. And so then we're going to do this. I mean, this scan tool again is walking us directly through it here. And so we're going to go above 3,500 and then return to idle speed. So kind of like what we were doing with the GMs, right? We're bringing the engine RPM up and we're letting it off, and now it's going to come back to idle. And at that point, the crank sensor is going to be reporting to the PCM what it's reading off of the crank sensor at that point. And so on that deceleration, it's an unloaded engine, and so it should be uninterrupted. You might recall in some of the earlier versions, you would actually take it out on the road and do multiple closed throttle decelerations. That's kind of the same thought there. But again, on the road, imagine if the torque converter is locked up and you're on a bumpy road, it's going to jar and it could skew this profile learn. So that's why now Ford is asking us to do it right there in the bay. And when it's done, test is complete, turn the ignition off. At that point, we should be good with it. So if we don't do this, what might happen? Well, we might have partially skewed timing, probably not enough to cause much of a drivability concern, but it's certainly going to affect the misfire detection system. And so if you get a P0300 many times, there's been a lot of times where I've just gone ahead and done a crank relearn to refresh the image in the PCM there and then take it for another test drive. Now it's easier and more clear to identify a particular single cylinder misfire. So keep that in mind. The next thing, again, it's not necessarily a sensor relearn, but it's a system relearn here, is talking about fuel trims. And so when the vehicle's in closed loop and we're using the O2s or the air fuel sensors to give a feedback to adjust the injector command, that's our closed loop. If we have too much fuel, too little fuel, that's the PCM making the adjustments here. And so one thing is when we're done making a repair that affected fuel trims, let's say we've had a lean condition and we fixed whatever condition that was, now we need to go in and clear keep alive memory or reset the memory. Now, I'll say myself, many times I like to take the vehicle on a test drive post repairs. If it was maxed out fuel trims, like positive 25, it's peaked out, I make the repairs, I'm gonna drive the vehicle and watch it start to relearn or fix itself at this point as it returns it back closer to zero. That's letting me know, hey, my repair actually fixed the job. However, in best practice, I'm still gonna stop, I'm gonna clear the memory and reset it to zero and then I'm going to continue on my verification test drive to make sure that it's not going back up. And again, sometimes if we don't clear that, the vehicle owner may come pick up the car and they're going to take it off your lot. And who knows, those fuel trims might be elevated yet. They're not watching a scan tool, but there may be some drivability concerns at that point. And so we need to be aware of that. And so it's always best to follow service information. And many times we're going to be resetting the keep alive memory there. So now as we look at one of the issues in which we might be actually resetting this fuel trim is when there's a flex fuel vehicle. Now, maybe you're familiar with flex fuel vehicles or even having too much alcohol or ethanol or E85 fuel available. Me being from the Midwest, there's a ton of stations that sell E85, but not every vehicle is equipped or E85 compatible. And the manufacturer strategies have certainly changed significantly throughout the years here. And so some of the earlier vehicles came with a fuel composition sensor. Recently, I worked on a 2015 Chevy Silverado. You can find the video of that on our YouTube channel as well. But the fuel actually goes through here. It senses and it sends out a frequency signal to the PCM to report on how much alcohol content is in the fuel. But many vehicles for a long time now have used a virtual flex fuel sensor. And so the way that works is the customer pulls up to the filling station ideally. They're going to shut the engine off. One more reason why you have to shut the vehicle off when you refuel it. Now the vehicle identifies that there's a refueling event, right? It's looking at the fuel tank level sensor, and so it sees, man, it went from 0% or 2% all the way up to 100% now. A refueling event has occurred. Now when the consumer starts the vehicle and it goes into closed loop, the PCM is going to monitor the O2s here and sees if all of a sudden, man, it went from running at 0% fuel trim to now it's running significantly lean. The likeliness of a vacuum leak or a sensor failure or something like that's pretty minuscule at that point. And so it determines if it's significantly leaner after a refueling event. Now they must have put higher alcohol content fuel in the vehicle, and vice versa. If it's determined it's running high alcohol content, a refueling event has occurred. Now all of a sudden they start the vehicle and it's significantly richer air fuel mixture than it was before. Well, they might be driving a Ford with a stuck open purge solenoid, but in many cases it's going to assume that the mixture has changed. And so that's how that virtual flex fuel sensor works. So talk about what happens here. The injector pulse width is recalibrated, fuel trim is reset to 0, and then the fuel trims return back to normal operations here. And so that allows these E85 vehicles to run at the 0% fuel trim. However, how many times have you run into it? I know it's happened many times in my scenario where somebody had a vehicle that was not E85 compatible and they put it in simply because it was significantly less money. Or perhaps somebody's on a cross-country trip. You know, many of the truck stops in Iowa, you're going to find E85 and they go, wow, this is 60% of the price of regular fuel. I'm going to put that in. And their vehicle's going to run terrible after that if it's not E85 compatible. And so quick ways to determine if it is or isn't, you'll find on the gas cap, if it's bright yellow like this or there's markers here, there's going to be clear indicators to many of us if you actually look at it. Now, again, that requires you actually looking at it or cracking open that owner's manual in the glove box to find out if the vehicle is E85 compatible. I've got case study after case study after case study where somebody's put the wrong blend of fuel in the vehicle and it ends up in a lean drivability condition. And so significant fuel trim shifts on those particular ones are going to require a keep alive memory, especially in Ford. There's a scan tool button right there. And so you can very quickly and easily reset the fuel trims there and start back to 0. If you don't do that, in these extreme cases, the vehicle is going to run terrible, even if you put the correct fuel in it because the mixture is so far off. So keep that in mind. There is quite often the issue of fuel contamination. In this case, it's E85 fuel that's, it's truly good fuel, but not for the vehicle it's put into. So part of our diagnostic process there, and certainly part of our repair process, is putting the correct fuel back in the vehicle and resetting the fuel trims there. Now, one of the next critical sensor relearns I want to address here is brake pedal position sensor or switch. And so here's an image of a GM brake pedal position sensor. And this is one of the ones that definitely needs a relearn anytime it's been touched. Now, Volkswagen is another one that comes to mind. There, I said VW twice in today's presentation, but it's they're very sensitive, especially in today's newer start-stop vehicles, where the vehicle has the brake pedal depressed, and as the vehicle shuts off at a red light, now as the driver starts to lift their foot, this very sensitive sensor is going to detect pedal position lift, and now it's going to re-engage the starter and start the vehicle there. So if we take it off and put it back on, it might be okay, but chances are it's going to be off by a couple degrees, and that's going to cause a delayed restart event. And it's going to have effect on different systems on the vehicles. Remember back in the old days where brake pedal position sensor or brake switch just made the lights on the back of the vehicle come on or off. Then I got involved with torque converter lockups. Now it has a lot to do with different strategies, electronic throttle control strategy, traction control on the vehicle. And so there's a lot of different things here that are going to have to do with the position of this. And so it's crucial. Even today, I run an F-150. I've got it out in the parking lot here. I haven't dug into it yet, or I haven't even tried the recalibration yet, but it's very noticeable. When I pull into a parking spot and put the vehicle in park, it's not sensing the pedals down as far as it is. So I get a warning message on the dash that says, vehicle's been placed in park without pressing the brake. Like, yes, I did apply the brake here. And so that's one of the things I'm going to do after this as a favor to the rental company, is do a recalibration. It's also for my own curiosity there, but I'm very certain that a recalibration of that brake pedal position sensor is going to make that message go away and allow the electronic parking brakes to function more properly in that. So this is super crucial, as I mentioned, on all the start-stop vehicles, especially on General Motors. And so that's one of those things you can go into most scan tools. Here's an example of using a snap-on scan tool on a Chevy Traverse. And so you can go into the output test here, and you can very easily see that. Other scan tools do the same. And so in preparation for this, I've got another video. And so I'm going to just kind of jump us into this, and let's take a look at what goes into recalibrating this brake pedal position sensor. On today's quick little tech tip, we're going to talk about the recalibration procedure for a brake pedal position sensor on a GM truck. Now today we're working on a 2015 Tahoe, and we replaced the brake pedal position sensor. And it's a relatively straightforward procedure. You know, there's not a whole lot to it, but this last step, the calibration, is one that quite often technicians overlook, and where it gives them problems when it comes to the start-stop system, the start function. And so we need to make sure that the control module understands that we've replaced the component and that we've got a new value in there. So if we look at the scan tool here, I'm pull up the control unit screen, and I'm going to click on body control module. Now again, a lot of technicians are tempted to go to the electronic brake control module. There's a pressure switch calibration test in there, but we want to be in the body control module. So I'm going to select body control module. I've already got the key on in the vehicle, and I've got the parking brake applied. So now that we're in body control module, I'm going to select special functions, and you'll notice right on the top here is brake pedal position sensor learn. So I will set that. I will select that. Then it says the test will learn the released position of the brake pedal. Apply the parking brake. We've already done that. Now I'm going to hit continue to start it. So you'll notice that it says brake pedal sensor learned value released position. Yes, but we still need to relearn it here. So I hit the learn button. It's going to grayed out while it's thinking. And just like that, it's done the relearn. Now I can escape. I can exit the procedure here. I'm going to go back to the vehicle and I can power the vehicle off. But at this point, I'm confident that I've done the relearn procedure here. Again, failure to do this might have some negative consequences with the start-stop system, as well as some other features on the vehicle might be disabled because the learned value of the new switch might be slightly different than the learned value of the previous switch. Hopefully now you understand why this procedure is so critical after replacing the brake pedal position sensor. All right, well, hopefully now you understand how straightforward that is. I'm going to say you can do any recently updated aftermarket scan tool, certainly with the OE scan tool. So next time you're servicing one of those, make sure you do the recalibration. Another newer category here is battery current sensors. Now these come in a variety of shapes, sizes, and locations, but you've probably noticed them on any vehicle in the last 10 years that you pop the hood on. And so if you're replacing the battery, you need to do a system relearn. Remember, the purpose of these is to monitor the charging system. And so let's not full field that alternator if we don't need it, right? However, as batteries age out, now the charging strategy is going to be different. So if you replace the battery, you need to do a relearn procedure on that. If you replace the alternator, you need to do the relearn procedure on that. If you replace the sensor, in many cases, you need to do the relearn procedure. So once again, I filmed another quick little video here, and so let's take a look at what it takes to replace that. Anytime the battery is replaced, or in this case, we've gone ahead and replaced the battery current sensor, we need to go into the scan tool and reset it. And so in this particular one, there's a little different menu here, but it's under service procedures, battery monitoring system reset. And basically I'm going to follow the instructions here, and it tells me when we should be doing this. Yes, we're going to follow through. It's about an 18-second process. And once it times out, we've gone ahead and reset it. So remember to do this anytime you're replacing the battery, probably also the alternator, the battery current sensor, anything with a battery management system on today's modern vehicles. Okay, well, once again, hopefully you understand how straightforward this is and how we can do with our aftermarket scan tools here. So a lot of this stuff, we're not doing any big tricky stuff. It's just blocking and tackling, right? It's the fundamentals. We're doing the job properly. Another key category here is steering angle sensors, or anytime you're working on a clock spring. That's going to be used for many different systems on the vehicle, particularly ADAS, and as well as collision avoidance and other systems here. The vehicle needs to know where the steering wheel is pointed at for all systems to operate properly. And so if you go into different service information categories here, it's going to tell you to do a steering angle reset after alignment is done. Anytime the steering column or the shaft has been disconnected, reconnected, or any repairs done. Certainly if the rack and pinion or the steering gear has been replaced. Steering angle sensor repairs. So if we replace the clock spring that has it in it, anytime we've touched something like that. And this is an often overlooked one here, restraint control module replacement. Quite often people will do a relearn or set up the module. This is a very important part of it because quite often the steering angle information is going to be stored inside of there. One tech tip is make sure if you want to verify that's been done properly, now we're going to turn the steering wheel lock from side to side and then bring it back to zero. Obviously it should be at the zero position going straight ahead. Many times you're going to find it might be as much as 10 degrees off center. And so it's important to do that recalibration at that point. And with it, you might want to look at the yaw sensor and see if it needs to be calibrated as well. Now, one more system here, and this isn't necessarily a sensor, but it's an important system that has to be relearned or recalibrated after repairs have been made, is the transmission adaptives here. And so if you've done transmission repairs, even sometimes replace an input speed sensor, an output speed sensor. If you've done a service to the vehicle, you need to do a adaptive there. I can think of the older Chryslers, where you had to do the adaptive numerator relearns there, and fill in the cavities. And so you have to go through the different gears as part of the procedure there. General Motors is quite fond of this, and so here's one example of when it should be done, because it's done as a wear compensation. And so as the transmission wears on and components get older and it's starting to compensate and apply more pressure, more pressure, more pressure. Now if somebody goes in, updates or rebuilds the transmission or replaces components in it, now the shift strategy needs to be reset, and it needs to go through that relearn procedure to understand how to apply each clutch properly. If you don't do that, it could burn out the new transmission in a matter of miles, and the customer may have some serious concerns. Now myself, I prefer good firm shift. I'm a hot rod guy, and so I like to feel the shifts, but not everybody does, especially in today's modern vehicles here, where really we very rarely feel the shift points there. And so it's important to reset adaptives after working on the transmission. And so the last category I'm going to cover here today is diesel emission sensors. Now, again, there's a ton of different categories I could cover, but this is what I want to kind of wrap up with here. Recently, I was called into a shop. They replaced NOx sensors on a GM L5P Duramax, and the light wouldn't go out. Well, they had not done the NOx reset procedure there. Same thing goes on if you're the particulate sensor or some of the O2 sensors. Also, if you're doing DPF, any of the DEF injectors or any of those related components, or the DOC, look in service information. There's a ton of resets and re-enablement criteria required for these particular things. So 95% of the time I'm called out to a shop to help out with a diesel emissions related issue. It's because they've not completed the relearns here. And so this is looking at the 2018, the NOx sensors. You can barely see it here, so I zoomed in. And so it's going to tell us install any components or connectors, perform any adjustments, programming setup procedures, clear trouble codes. If replacing, perform the NOx sensor reset. And so literally I could go into the snap-on scan tool, go into output controls, there's NOx sensor reset, select yes, okay, test completed. And so once you're done with that, now it says perform the NOx catalyst reduction loading reset. So it's not saying I have to do a whole regen or anything here. It's just another enable criteria that I say yes to, and now it's going to reset there. So we've done our regen enable. Again, we don't have to necessarily do it here, but we've gone in the scan tool and kind of cleared out the pre-existing conditions and reset the counters back to 0. And so now the next test drive, I'm sure this thing's going to regen pretty quickly here. But by simply doing that, the check engine light stayed out and these codes did not return there. So once again, anybody can install the sensors, but you have to go down to the bottom here and it says repair verification. And that's the crucial piece of today's message. Part of the repair verification, we're doing what it takes to finish the job off here. So kind of summarize what I've covered here today. Make sure we look in service information to see if a relearn is required before we even start the job. Now we're going to do the relearn after, but before we even touch the vehicle, want to make sure that we've got the equipment, we've got the knowledge, and we've got the subscription to any OE software, anything like that that we might need here to be able to truthfully finish the job here. Read the system information thoroughly. Now, quite often, I'm guilty of just skimming over, and so that's where many times we have to, I had to grab my reading glasses and sit down and focus and read what the service information is, and make sure we follow those instructions precisely. Sometimes, again, I've done this, I've done it. Yep, I got it. There might be a caveat in there that's different than what's in your head here. And so we need to make sure that we follow step by step through it. And then we're going to verify the repair. We're going to take the vehicle and test drive it and make sure that we actually completed the repair versus just giving it back to the customer and going, yeah, I think it's good. And so we want to make sure that we're very confident and we verified the repair there. So as I had mentioned, there's a lot more information on our YouTube channel. Go to Standard Brand YouTube. And so you can see here, I just actually searched Relearns. And so that crank sensor tip I shared here earlier, that's in here. The Nissan Throttle Relearn, we've got TPMS Relearns. And so a lot of these type of Relearns are available on there and a lot of other good information. You can also go to standardbrand.com, look on our website for more information there. And every month we change it up. We've got more tips, more information, more product information. You can look up catalog stuff there too. Recently I was at a class and heard a group of technicians go, wow, I didn't know I could buy that in the aftermarket here. I thought that was an OE dealer only. And so quite often we're amazed at what's available here, as an aftermarket solution. So that does it for my presentation. Now I'm going to open it up. I see there's a couple questions here, and Patrick's addressed some of them, but what are some of your favorites here that you want to share on air, Patrick?
All right, well, we've got Craig here. He's asking the question, what if I do, or if I don't, do a sensor relearn?
So, yeah, what happens if you don't? Now, it's obviously going to depend on the system there. Think about one like this diesel one I just shared here. The light might come right back on, or the vehicle might still be in limp-in mode. If it's like a crank sensor that I talked about earlier, you might get a P0300 instead of a specific cylinder misfire there. Or in some cases like the fuel trim or the electronic throttle or the APP, we're still not going to have the system operating properly. So some vehicles, you might not even notice it, and some vehicles, you're definitely going to notice it. So best to do it.
And then another question here from Sean. Have you seen it where one vehicle does a certain procedure and a similar vehicle does a different procedure?
Yeah. I think I'm being set up here by Sean. Because yes, I've done that before, right? Oh, I just worked on a Ford Edge last week. I got another Ford Edge in here. I know what it is. The manufacturer may have changed the procedure, may have done a TSB update with it, and there might be a mid-year change or something might be a little different. So I can't stress enough that we need to go in and look up specifically for the vehicle we're working on. Don't try and stretch it or even lie to the scan tool. I want to force this thing to do a relearn. Well, if it won't let you do a relearn, maybe that's for a reason too.
And then we've got Kyle. He's asking, did you say the crank relearn should be done after a transmission replacement?
Yes, absolutely, because that torque converter, the clutch is going to be bolted to the flywheel, which is bolted to what? The crankshaft. And so the crank sensor is going to be reading it. Anything that's bolted directly to it or going to affect the rotation of the crankshaft is going to require a crank relearn or a misfire neutral position relearn or whatever Ford calls it this particular week or different manufacturers. So yes, if we're doing drive line related repairs, many times a crank relearn is going to be recommended.
And then this last one from Wade is not so much a question, but more of a comment. Maybe you could add a comment to. He says, good information. It seems like anytime I have to follow up on someone else's work, it's because they didn't do the relearn procedure properly.
Well, thank you, Wade. I appreciate it, and your checks in the mail for that. But yes, similar, especially in the diesel world. I get a lot of guys that are good at replacing components, but these crucial or critical relearns are required at the end of it. If somebody doesn't do it, I've seen a truck towed from the Upper Peninsula of Michigan back a couple hundred miles to a shop simply, and everything was done properly, but they forgot to do one of the relearns there and put the truck in limp-in mode. And so sometimes it's as simple as hitting that button and understand the service information.
All right.
So if that's it, I'm going to close it out here. Thank you all, and we look forward to seeing you next month at the Power Hour.